LTC4222 Dual Hot Swap Controller with I2C by Linear Technology. Welcome to the training module on Linear Technology's LTC4222 Dual Hot Swap Controller with I2C. This training module will review the key features and operations of the device. LTC4222 Dual Hot Swap Controller is for protecting boards with multiple load supply voltages ranging from 2.9 volts to 29 volts. The device enables safe mode insertion and removal from a live 2-supply backplane by controlling external N-channel MOSFETs to limit the inrush currents during power-ups. An I2C interface and 10-bit A to D converter allows users to query important information such as card currents, voltages or fault status, and use it to assess the health and integrity of the power distribution network. During startup, inrush currents are safely controlled using current foldback, soft start, and DIDT limiting techniques. Load currents are monitored using the voltages sensed across current sense resistors and controlled by adjusting the MOSFET's gate to source voltages accordingly without the need for external gate component. LTC4222 is suitable for a wide variety of electronic circuit breakers, computers or servers, and platform management applications. The functional diagram shows the monitoring blocks of the LTC4222. The group of comparators on the left side includes the under voltage or UV, over voltage or OV, reset, RST, enable or EN, and on comparators for channel 1 and 2. These comparators determine if the external conditions are valid prior to turning on their corresponding gate. The two under voltage lockout circuits, UVL01 and UVL02, validate the input supplies and the internally generated 3.3 volt supply, I2C. UVL02 also generates the power-up initialization to the logic circuits as I2C crosses this rising threshold. The two channels share the timer and soft start pins that control startup behavior. A typical LTC4222 application is in a high availability system in which two positive voltage supplies are distributed to one or more cards. The device measures card voltages and currents and records past and present fault conditions for both channels. The system queries each LTC4222 over the I2C periodically and read status and measurement information. A basic LTC4222 application circuit is shown in the figure. The following pages will introduce the basic operations of the LTC4222 based on this circuit. The power supplies on a board are controlled by using external N-channel pass transistors Q1 and Q2 placed in the power path. Resistors R1N, R2N, and R3N define undervoltage and overvoltage levels for the two channels. R5N prevents high-frequency oscillation, and on and R6N. C1N forms an optional network that may be used to provide an output DVDT limited startup. Here lists several conditions which must be present before the external MOSFET for a given channel turns on. After a power-on reset pulse, the LTC4222 goes through the following turn-on sequence for one or both channels. First, the UV and OV comparators indicate that input power is within the acceptable range, which is indicated by status bits 0 to 1 in Table 5. Second, the enable pin is externally pulled low. Finally, all of these conditions must be satisfied for the duration of 100 milliseconds to ensure that any contact bounce during insertion has ended. Additionally, if the configure pin is low, and all initial conditions for both channels must be met before the pair are allowed to turn on together. One or both gate pins are turned off by a variety of conditions. A normal turn-off is initiated by an on pin going low or a serial bus turn-off command. Additionally, several fault conditions cause the gate to turn off. These include an input over voltage, input under voltage, overcurrent circuit breaker, or the enable pin transitioning high. Writing a logic 1 into the UV, OV, or OC fault bits also latches off the associated gate, if the auto retry bits are set to false. The MOSFET is turned off with a 1 mA current pulling down the gate pin to ground. If the INT VCC pin drops below 2.6 volts for greater than 1 microseconds, or the associated VDD pin falls below 2.35 volt for greater than 2 microseconds, a fast shutdown of the MOSFET is initiated. The LTC4222 has different current limiting behavior during startup when the output supply ramps up under timer, soft start, and FB control and normal operation. As such, it can generate an overcurrent fault during both phases of operation. Both set the fault supplies overcurrent fault bit and shut off the faulting gate, or both gates if the configure pin is low. An overvoltage fault occurs when OV pin rises above its 1.235 threshold for more than 2 microseconds. This shuts off the corresponding gate with a 1 mA current to ground and sets the overvoltage present status bit 0 and the overvoltage fault bit to 0. If the pin subsequently falls back below the threshold for 100 milliseconds, the gate is allowed to turn on again unless overvoltage auto retry has been disabled by clearing control bit 0. If the configure pin is tied low, an overvoltage fault on either channel will shut off both channels simultaneously. An undervoltage fault occurs when the UV pin falls below its 1.235 volt threshold for more than 2 microseconds. This turns off the corresponding gate with a 1 mA current to ground and sets undervoltage present status bit to 1 and overvoltage fault bit to 1. If the UV pin subsequently rises above the threshold for 100 milliseconds, the gate is turned on again unless undervoltage auto retry has been disabled by clearing control bit 1. When power is applied to the device, if UV is below its 1.235 volt threshold after INT VCC crosses its 2.64 volt undervoltage lockout threshold, an undervoltage fault is logged in the fault register. If the configure pin is tied low, an undervoltage fault on either channel will shut off both channels simultaneously. The LTC4222 incorporates a 10-bit A to D converter that continuously scans 6 different voltages. The source pins have a 1/24 resistive divider to monitor a full-scale voltage of 32 volts with a 31.25 mV resolution. The ADN pins are monitored with a 1.28 volt full-scale and 1.25 mV resolution, and the voltage between the VDD and sense pins is monitored with a 64 mV full-scale and 62.5 microvolt resolution. Results from each conversion are stored left justified in registers and are updated 15 times per second. The data converter also has a direct address mode that allows the user to take a specific measurement at a specific time and hold that value for later readback. Here shows a detail about board present change state. It uses enable pin for checking the status. If a connection sense on the plug-in card is driven at enable pin, insertion or removal of the card may cause the pin voltage to bounce. This results in clearing the fault register when the card is removed. The pin may be debounced using a filter capacitor CEN or the enable pin. The LTC4222 communicates with the bus master using a 2-wire interface compatible with I2C bus and SM bus and an I2C extension for low-power devices. The LTC4222 is a read-write slave device and supports SM bus, bus read byte, write byte, read word, and write word commands. If either the SCL or SDA lines remain low for more than 25 milliseconds, the LTC4222 will reset its interface and release the SDAO pin, freeing the bus to resume communication. The LTC4222 also features PM bus compatibility. The interface will not acknowledge unsupported commands. 27 distinct bus addresses are available using 3 state addressing pins. The LTC4222 corresponds to 2 special addresses. Address 1100-01110 is a mass write address that writes to all LTC4222s, regardless of their individual address settings. Mask write can be disabled by setting register bit 4 in the control register of channel 2 to 0. Address 0001100 is the SM bus alert response address. The acknowledged signal is used in handshaking between transmitter and receiver to indicate that the last byte of data was received. The master begins communication with a start condition followed by the 7-bit slave address and the read-write bit set to 0. When any of the fault bits in the fault register are set, an optional bus alert is generated if the appropriate bit in the alert register is also set. If an alert is enabled, the corresponding fault causes the alert pin to pull low. After bus master controller broadcasts the alert response address, the LTC4222 responds with its address on the SDA line and then release alert. The alert line is also released if the device is addressed by the bus master.